So let's look at example 2, which is saying that a car of mass 1000 kilograms is accelerated at a rate of 2 meters per second squared by a driving force of 2 kilonewtons against a constant resistance. Find the resistance to the motion of the car. Okay? So we are now saying that if I have a car of mass 1000 kilograms, is accelerated at a rate of 2 meters per second squared by a driving force of 2 kilonewtons against a constant resistance. Find the resistance to the motion of the car. So I can now summarize and say my mass is 1000 kilograms, my acceleration is 2 meters per second, okay, and the force F is the same as 2 exponent 3 Newton. To remove kilo, multiply by exponent 3, okay, to remove the kilo. And then if R1 is the resistance, it is what now is needed from us. So a simple sketch for elaboration, I can say if I have this, I have this driving force here that has been given as 2000 Newton, or the same as 3 exponent 3. And then I have the car which is having some mass, okay? This is relevant force, even if I don't put it there. And then I have a resistance R1. This body here is going to accelerate at a rate of 2 meters per second squared. That is what is happening. So I can now say, using F equaling to MA, okay? F is the force in the direction of motion minus force opposing motion. So we can say force in the direction of motion is 2000 minus the force opposing is R1. Is that okay? And then should be equaling to MA. What is my M? My M is 1000 times 2. Okay? That means that my 2000 minus R1 equaling to 2000. And that means that R1 equaling to 0. So that means that the resistance to the motion is 0 Newton. Okay? Because if you bring this side, take the other one, the resultant will be equivalent to 0. So that means that the body which is moving with these properties will have a 0 will have a 0 resistance to its motion. Okay? So let's now also have a look at our next example that is still involving the use of the Newton's second law.